In letter B, the next question in the list of problems I'm going to try to do an example of, we're now dealing with the multiples of 5 between 5 and 505 inclusive. So just like I did in the first problem, I want to first make sure that I understand which numbers I'm adding so that I can better understand what kind of problem I'm dealing with, whether it's finite arithmetic, finite geometric, or infinite geometric. So I'm just first going to do a little bit of scratch work here, and I'm going to think about the multiples of 5 that somehow are in this list. 1 is not a multiple of 5, 2 is not a multiple of 5, 3 is not a multiple of 5. And technically, I mean, if you think about it, we're limiting ourselves to be between 5 and 505, so the first number in the list must be 5. But then I have to think, what would come after 5 in this list of numbers? Not 6, because that's not a multiple of 5, not 7, not 8, not 9. 10 is a multiple of 5, though, so 10 would be included in the list of numbers I'm trying to add. Not 11, not 12, not 13, not 14, none of those are multiples of 5, so 15 would be included, but not 16, 17, 18, 19, and then 20 would be included. And you can tell I'm going to keep doing this for a while. But if I think only of the multiples of 5, 5, 10, 15, 20, 25, 30, 35, 40, I can definitely keep counting all the individual terms, but that's going to get kind of tedious because I have to go all the way up to 505. So let's fast forward in our heads for a second. What would happen by the time you get close to the end of this list? You would have 495, then you'd have 500, and then you'd have 505, and then you'd be done. Now the reason we say inclusive is because we want to include 505 in the list. We want to include the first term 5 in the list. If it says exclusive, or if it doesn't say the word inclusive at all, that implies that those two end numbers aren't included in the list. So it's a good thing they told us, otherwise we'd have that guesswork, like, do we include it or not? They specifically said include them. That's what inclusive means. So thinking about the pattern here, this is definitely finite because I had a distinct ending point. It told me to stop at 505. That was implied from the question. So this is definitely not an infinite series, which narrows down which formulas I might have to think about. Then I just have to think about the pattern here. 5, 10, 15, 20. That's adding by 5 if I evaluate that pattern. And since I'm adding 5 to each term to get the next term, that means it must be arithmetic. This is another finite arithmetic question then. So notice that thought process that goes into it. First, narrow down whether you have a finite or an infinite series. Then, try to narrow down whether your pattern is arithmetic or geometric. That should help you land, by process of elimination, on one formula that you know you can use. Now that I know this formula is going to be for the finite arithmetic, which I can conveniently steal from question letter A, I'm just going to apply all of the same thinking with this series of numbers in mind. So 1/2 times a sub 1 is the first term in this scratch work was 5, plus a sub n. A sub n is the last term in my scratch work, that was 505, times a sub n again, 505, minus first term, 5 again, divided by the adder. The adder in this pattern was 5, plus 1. So again, you can do this in your calculator, you can do this however you want. Some people do the more complicated part in their calculator first, and then they go back and simplify the rest. That would be fine if you want to clean up the problem. And some people do some of the steps in their head and then just use their calculator at the very end. So I'll leave that up to you. If, for example, you wanted to do this partially without a calculator, 5 plus 505 is 510 in that first parentheses. Then in the next parentheses, 505 minus 5 is 500. 500 divided by 5 is 100, plus 1 would be 101. So into my calculator, I could type a condensed version of things. I could type 1/2 times 510 times 101, and that way I don't have quite as many tedious parentheses and fractions to type in. Totally your choice, you decide, but it looks like the sum is going to be 25,755. Again, whoops, it does seem as though that answer is reasonable, because by the time I really think about adding up all of those individual terms, it really does stand to reason that I should expect a very large number. I mean, just adding 505 and 500 alone is already over 1,000. Add 495, you're already up to 2,000. I mean, that's a gigantic number already, and that's just the last three terms. If I added all of the other terms in between, then I'm definitely going to get to the point where I would say, ooh, yeah, okay, I'm kind of done here. I've got as many as I can do. So that's why it's helpful to have that formula, but also some context to say to yourself, does that answer make sense? Sometimes people have a typo in their calculator and they get an answer of, say, like negative 729,000. And when you think about it, that doesn't make sense. If you're adding all the positive multiples of 5 between 5 and 505, how would you get a negative answer? So if you get an answer that just makes no sense, it's either a really small number or a negative number or a number that just seems weird, go back and check. Maybe it's something really simple like a typo in the calculator. Maybe it's something else really simple, like something accidentally got switched around in your formula and you just need to make a quick fix. So just be attentive. Look at your answer, compare it to the answer key, but use your instinct. Tell yourself, yeah, that makes sense, or that doesn't sound right, so that you can start building that intuitive feeling for what these problems and their answers should start to look like.